Hi everyone. Today we are talking about radical expressions. So if you were to open your book, you would find this on page 299, but I've created a note sheet for us. But let's take a look at our two learning targets. We are going to write and simplify radical expressions, and then we are going to understand what is meant by a rational exponent. So our previous activity was all about exponents, and we're going to see how those relate to radical expressions. So I have taken what the book is teaching and I've put it into kind of a fill-in-the-blank note sheet, basically. So we are going to start out by talking about perfect squares. A perfect square is any number A if and only if we have a number multiplied by itself to equal A. Or another way to write that using our exponents is that B squared would equal A. So let's fill in our perfect squares. Okay, so 1 times 1 is what I want to think about, or 1 squared. 1 squared is 1. So here, 1 is a perfect square. Okay, what is 2 times 2, or 2 squared? That would be 4. So 4 is considered a perfect square. All right, let's keep going. 3 squared. So 9, 16, 25, 36, those are perfect squares. All right, let's keep going. Some of you might have these memorized. $49 is a perfect square, 64, 81, 100. And what about, what's 11 squared? 121. What is 12 squared? 144. Let's go to 15. So 13 squared. I'm going to continue to highlight the perfect squares just to point those out. So these numbers are considered perfect squares because a number multiplied by itself, or that number squared. All right, so it's important that we have this list in front of us. And then we're going to talk about what a radical expression is. So if I am looking at this symbol right here is our radical symbol, or a radical sign. Sometimes we just say it's the radical. Okay. The number underneath the radical, so the A here, is called our radicand. The n is our root index. And if there is no root index listed, we just always assume that it equals 2, that n equals 2. And B, whatever our answer is, that is the nth root of A, which is our radicand. So sometimes we might have the square root, which is a 2, and it's not always written there. And then we have a cubed root, a fourth root, etc. So B would be the nth root of A, and A is the radicand. Next, the book talks about fractional exponents to kind of tie in what we've learned before into what we're currently learning now. So if we look at this, a fractional exponent can be written as a radical. Okay? So I'm going to write my radical symbol. And the base becomes our radicand, so it goes under the radical. The numerator, the 1, becomes the exponent underneath the radical. And the denominator, this n, is our root index. Now, the next one, what if it's not a 1? Okay, so A is the base, and that's still our radicand underneath our radical. This time, the numerator n, still our exponent, n, the denominator, is our root index. And this could also be written using parentheses with the m outside the parentheses. Okay, so let's try to switch back and forth between these two. We're going to take our fractional exponents and we are going to write them as a radical expression. Okay, so just a reminder, we're going to start with our radical symbol. 6 is the big number, that's the base. So that goes underneath my radical, it's the radicand. This numerator is the exponent. So you can put a 3 right there. Oops, sorry. You can put a 2 right there. And then our denominator becomes our n, or our root index. So that would be the 3. Next one. Let's start with our radical symbol. Our base is the 13, so that goes underneath. That's our radicand. The numerator is our exponent, so we're going to put a 1 there. And then this 4 is our root index, our n, so we're going to put it right in there. Letter C. Draw our radical. 7 is the base, so it goes underneath your radical. Stays as our large, big number. This is going to be our exponent. The 5 is our root index. All right, you try letter D. x is the base, so that goes underneath, becomes our radicand. This is my exponent, 3, so I'm going to write a little 3. And then this is my root index here, so we could put a 2. Or I'm actually going to take this and delete it. There's not a root index. Remember, if there is no root index, we assume it's a 2. So we're going to add that to the top of the next page. So a square root is a radical whose root index is 2. Okay, so that means I'm taking the square root, the square root, the square root of all of these problems, but we don't write the 2, we just assume that it's there. Okay, so these questions are from your book, and these are all perfect squares. So finding the square root of a number is the inverse, or the opposite, of squaring a number. So that's why exponents and radicals undo each other. So if I'm saying what is the square root of 25, the answer is 5. Why? Because 5 times 5, or we could say 5 squared, equals 25. So again, finding the square root of a number is the inverse, or the opposite, of squaring a number. So what's the square root of 81? What number squared equals 81? Or what number times itself will give us 81? And that answer is 9. So 25 is a perfect square, the answer is 5. 81 is a perfect square, the answer is 9. Now what about the square root of x squared? This answer is going to be x. Why? Because x times x, or x times x equals x squared. Or you could think about this as a fractional exponent. So if I have x, 2 divided by 2, that becomes just x to the first power, which is x. So think about if I'm squaring a number and taking the square root of that, they cancel each other out. So our answer would just be x. So that's what makes those numbers in the very beginning perfect squares. What happens if we don't have a perfect square? We need to simplify those radicals using these 3 steps. If they're not a perfect square, that's important, not a perfect square. So, step 1, we are going to write the radicand, and remember, the radicand is the number underneath the radical sign. So for example, right here, 75 is my radicand. So we are going to write the radicand as a product. Product means to multiply, of 2 numbers. And it's important that one of those numbers is the largest perfect square that that number is divisible by. So we're looking for the largest perfect square that the radicand is divisible by. Then we're going to break it down using that number. Step 2, we're going to find the square root of that perfect square, and we take it out of the radical, and we put it out in front. Step 3, we're going to leave whatever is left over, our other number, underneath our radical. So you might have done this a little bit in middle school. I don't know how far you got with the shutdown, but let's look at these examples here. So the first one is the square root of 75. First of all, is that a perfect square? Is that on my perfect square list? No, I see 64 and 81. So I don't see a 75. So what I need to do is follow these 3 steps. So I'm going to break down 75. What is the largest perfect square that goes into or is a product or a factor of 75? So let's try to think about this. Could I do 75 divided by 64? No, it doesn't work. 75 divided by 49? Nope, it doesn't work. Is 75 divisible by 36? No. Is 75 divisible by 25? Ooh, yes, that works. So it's divisible by 25. And 25 times what? 3 gives us 75. So I've done step 1. I found the largest perfect square, and I'm breaking it down using that number. So 25 times 3 gives us the 75. Now, step 2, we need to find the square root of the perfect square, which is 5. Good. And remember, we're taking that out of the radical. So the radical, it's gone. I do not need the sign anymore. So I'm not going to write it. And then step 3, I'm leaving my leftover underneath the radical. So this right here, 5 square root 3 is my final answer. 5 times square root of 3. All right, let's break down 72. What is the largest perfect square that goes into 72? I know that 72 is divisible by 9, and some of you might have thought about that right away, but 9 is not the biggest. So I want to work largest to smallest on my perfect square list. I know 64 isn't going to work. 49 isn't going to work. So try 36. What is 72 divided by 36? It works. 36 times 2 gives us 72. Find the square root of the perfect square. So what is the square root of 36? We get 6. And we're going to leave whatever is left over underneath the radical. So this is our final answer. 6 square root 2. All right, go ahead and try 200. What is the largest perfect square that goes into 200? It's 100. And 200 divided by 100 is 2. 100 times 2 is 200. All right, let's find the square root of the perfect square. So what is the square root of 100? That's 10. And I'm going to leave the 2 underneath the radical. And that's my answer. Oh, this next one looks different because there's a 2 out in front. So what I'm going to do first is just break down this 54, and I'm going to bring down my 2 so I don't forget about it as part of my final answer. What's the largest perfect square that goes into 54? 49 isn't going to work. 36 isn't going to work. 25 isn't going to work. Does 16 work? No. Does 9 work? 9 times what is 64? 9, or 54, sorry. 9 times what is 54? 9 times 6 is 54. Okay, so again, I'm going to bring down my 2 so I don't forget about it. What is the square root of 9? That's 3. Leave the leftover underneath. But now let's take this a step further. All of these are being multiplied together. So 2 times 3 is 6. So 6 square root 6 is our final answer. Seven square root 12. Leave your 7 to start with. And break down the 12. Think. What perfect square goes into 12? What's the largest? That would be 4. 12 divided by 4 is 3, or 4 times 3 is 12. Okay, I'm going to bring down my 7. Take the square root of the perfect square, that's 2. Bring down the leftover underneath your radical, and then 7 times 2 is 14. 14 square root 3 is our final answer. The square root of c cubed. Okay, so what would be my nth root here? If it's not there, we assume it's a 2. Okay, well, is 3 a multiple of 2? Is 2 a multiple of 3? No, it doesn't work that way. So let's think about breaking this down, breaking it apart with a perfect square. So above, we saw that x squared was a perfect square. So c squared is a perfect square. Now, if I'm taking that out, I'm dividing it out. So let's use our exponent rules. What's 3 minus 2? It would just be 1. I just have a c left over. So now think about this as a multiplication problem. C squared times c would give me c cubed, which is what I started with. So we know we've broken it down correctly so far. Okay, and now let's keep going. Remember from earlier that the squaring and the square root cancel each other out, and we're just left with c. And then leave the other c underneath your radical. So c square root c would be the final answer there. What I need you to do now is open your book to page 300, and I want you to do the try these A questions at the bottom. You're going to see A through E, so I would like you to try those. Try to break down these questions. I know that I don't see a perfect square. 18 is not a perfect square, so go ahead and break it down. Oops. So we're going to write it as a product of two numbers. The first one is the largest perfect square that 18 is divisible by. So it would be 9 times 2 gives us 18, or 18 divided by 9 is 2. Take the square root of the perfect square, which is 9, and the square root of 9 is 3. Leave the leftover, and that's my final answer. Letter B. I'm going to leave the 5 and break down the 48. What is the largest perfect square? It would be 16. And 48 divided by 16 is 3. So take the square root of 16, which is 4. Leave the leftover. So leave the square root of 3. And 5 times 4 is 20 square root 3. Go ahead and keep going. I want you to do C, D, and E. If you have any questions, join Zoom or send me a message.